Hey, everybody, welcome to this special session where we're going to talk about automating log analysis and how you can find attackers and indicators of compromise in our logs. Almost every compromise that we come across could have been found earlier, and the actual impact on the organization could have been significantly reduced if people had been looking at their logs. But let's face it, looking at logs is difficult and boring and it's repetitive. And it's like looking for that needle in the needle stack every single day, right? You're going through there and you're not finding anything. And so you become complacent, and well, then of course, when you become complacent, then the attackers hit and you overlook those settings. So this is why automation in these situations is really useful, because it can take care of those repetitive tasks and do them well just as well or better than we could do them manually. So we're going to talk about how we can automate logging or analyzing our logs to look for indicators of compromise. This is a subject that we talk about extensively in my SEC 573 class. So we'll get a little bit of insight to that. Just a little bit of background about me. I'm a Chief Information Technology Officer for SANS Internet Storm Center. I'll tell you a little bit about that. I'm a faculty fellow for SANS. Means I've been instructing for them for a very long time, and I've written several courses for them. Among those courses are 573, Automating Information Security with Python, 673, which is an advanced version of that. I'll have a session later today where I'll talk about some 673 topics. I'm also the co-author of SEC 406 with Charlie Goldner, and done several things with the information security community, such as B-Sides Augusta and other things. I also host this InfoSec toolshed. I'll show you a little bit about that. Let me point out this last thing at the bottom, which is that if you look for my name in the Metasploit framework, you'll find it there 7 times. And this isn't because I've written anything for Metasploit. I actually haven't written any tools for Metasploit, but the information security community has been kind enough to give me credit for modules that they've written in information or in Metasploit, which were based upon other tools that I had written in other languages. So thank you for that. If you don't know, the Internet Storm Center, which I'm the Chief Technology Officer for, provides several services to you that are related to log analysis and are also very good. So you've got the D-Shield community database, where the Internet Storm Center has hundreds of distributed sensors, honeypots, 404 agents, and other things that are collected up. And all of that information is available to you in an API. So you need to know how to write a little bit of code to interact with that API and query information from the database. And if you don't know how to do that, again, I can teach you that in the 573 class. It's also where you hear that wonderful Stormcast podcast that comes out every day by Johannes Ulrich, and he's going to break down all of the latest security news. I love this podcast because it's short and sweet, 5 to 10 minutes every morning, and you got the latest up to date. You are up to date on all of the latest news. And of course, there's the Internet Storm Center with the Storm Center Diaries, where volunteers are monitoring that D-Shield database and posting diaries that are explaining what the latest attacks are and the things that you should be concerned about at work. And of course, the InfoCon, which has got a current threat level that we see on the internet regarding the risks and vulnerabilities. So if the InfoCon is orange, you don't want to come to work that day. It's really rare when it goes to yellow. So that's a little bit about the SANS Internet Storm Center and what services we provide there. As I mentioned, I'm the course author for SANS 573, which is one of the things we're going to be talking about today in this session. This course has 130 different hands-on labs, and we're going to be looking at one of these labs today as we dig into some log analysis. A little bit about where I am. I am sitting in a hotel. I really intended to be there with you live doing this presentation today, but this is a recorded session because Hurricane Helene has taken out everything in the city in which I live. And well, there's no power, and we're not expected to get power back until after this is live. So I'm in a hotel and I am recording this session in a hotel. And that's why you'll be watching a recorded session and not a live presentation. So I'm sorry for that, but circumstances are beyond my control. So let's just jump right into this and talk a little bit about 570. Actually, before I jump into it, let me mention one or two more things that I had here. Um, I want to mention the InfoSec Toolshed. So if you haven't seen it, the InfoSec Toolshed is a YouTube channel that I have. YouTube at Mark Baggett. It's a series of interviews with people who have created tools that have changed information security. If you'd like to know the origin story of Netcat, we all use it, we all know it, but where did it come from? And why was it written? What's the purpose of that? You can check out What is Netcat, or the origin story of Security Onion, or THC Scan, THC Hydra. So I've talked to the creators of many of the tools that we know and love in information security, just to capture the background on those. Okay, so that you can check that out, and I hope you'll enjoy those channels. But let's jump right into some log analysis and see how we can analyze some data. Okay, once again, I am in a hotel here, and you'll hear some background noise and things like that. My entire family is in the hotel, so I apologize for any background noise, but it is what it is. We are huddled up from Helene. So let's just take a look at one of the many labs that you'll have in SEC 573 to talk about how we can do log analysis. Here I'm in what we call the PyWars client. This is the lab engine that we have for 573. And here's just a list of the labs that are available as you go through this class. And we're going to jump down here right into, we'll say, lab 3.3.333 or 332, I think is what I'll do. I think I'll do 332 here. Let me just look at that one. But I want you to see before we jump into this that this is day 3. It's the afternoon of day 3. So there's a lot of prerequisite knowledge that's going into this. I'm going to try and summarize that information to the best of my ability in this 30-minute session that we have. So let's begin by asking for lab 333. Now, when we do this, it tells us that this DDoT question goes off to my PyWare server, which is our lab environment. It says, hey, give me the question for lab 333. And it says the data contains an IP address. Parse all of the DNS logs that are in this folder and return a list of all the host names that were queried by this IP address. So in this scenario, we're going to pretend like this IP address is an internal IP address that was compromised, and then it exfiltrated credit card or other sensitive data out to someone on the internet. So what we want to know is, going through all of the DNS logs, who did this IP address talk to today according to our DNS logs? And that's our goal. Now, if I ask for a DDoT question, it gives me the question. If I ask for DDoT data, it's going to tell us which IP address we want to get. Now, the reason these are separate queries is because that data changes every time. So what I have to do is programmatically write a program that gets this IP address, figures out all of the hosts that it talked to, and then submits that list back. And the way that you submit that list, you call d.answer, and you then give it the list that contains those IP addresses. I'll just put a single IP address in here just to show you that what I'm going to get back when I submit this single IP address is I'm going to get back a timeout, because I've only got 3 seconds from the time I ask for the data till the time I submit the answer. So we work our way up to this, but you're being forced to programmatically answer this question. Okay. Now, in order to help you along those lines, it drops a folder on your desktop. So if I cd into lab 3.3.3, I'll see that it's started for me a partially written program that will get me started. So here it's created this lab.py, which is just a shell of a program to get me started. You can see down here at the bottom, it creates a PyWars client for me, logs in, and then it's going to ask for the data, and it's going to pass that data to my function called lab333, which has been started for me here, but it hasn't been written. So whatever I write inside of this function is going to be called here. It'll submit the data and then take the results of that and submit it to the answer. So I just have to write this function. And what we have to do is let's turn on Alt-Z here to line wrap so I can see this full comment. Recursively go through all the logs that are in this folder. And then for every host name, we're going to look up that IP address and submit a sorted list of the results. Okay. So let's see how we would do that. Now, I teach you a couple of different ways to access files in this class. I'll teach you about using context managers and the traditional open, but the real way that we should analyze files is uh, to use a module called pathlib. Pathlib replaces all of the other ways that we've interacted with files in the past in Python, and it gives us one consistent interface into the file system. So I'm going to here, I'm going to say, I'm going to create a pathlib.path that points at this folder. Oh my goodness, copy and paste. Why are you so difficult? Could have typed it by now. All right, so I'll create this log path variable that points at that directory. And then I'm going to say for each file in log path, then I'm going to use the glob module. Glob says, I could say glob.*log or *.py if I just wanted the .python files. In this case, I want to go through every log file that's in there. Or actually, I don't even know that they're log files. I'm just going to say asterisk because I think that I want to go through all of the files that are in there. They might be text files, they might be log files. I'm not sure. And then what I have to do is I have to read the contents of each of these files. So let's say this. I'm going to say file content equals each file dot read text. And this will read the contents of those files. Now, again, we will talk more about what these things are and how pathlib works in more detail in 573. But what I'm going to do there is I'm just going to type that. I'm going to put the word pass here so that I can have it pause. And then I'm going to put a breakpoint here. I'm going to save my program. And then I'm going to try and run my program debugging it. Now, using the debugger is a great way to step through this program. Notice I'm not trying to write the entire function at once. I've just written a little bit, and then I create a breakpoint and I launch it. Now, when it runs, the breakpoint is reached and it hits that puts a yellow line where I am in my program. And down here, I can now see what's in the variables. So over here, I can minimize these. I can expand this out. I can see what's in each of my variables. I can see my file content has been read. I can see what the log path is. I can see what the current data is that was passed into it. So I can see my variables. I could actually click on these. I could change them if I wanted to. So I can come in here, change it, give it a different value. And again, we'll talk about how to use the debugger in some detail in 573. What I want to show you here is that when I hit this breakpoint, I can now come down to the debug console and I can begin experimenting with how exactly am I going to, well, get the data that I want to out of this log file. If we take a look at each, let's see, file content, a file content contains, well, all these IP address usernames, client IP addresses, host names, and so forth. All right, so what I want to do is get the stuff from the word client, and I want this IP address and this host name. So I'm just going to highlight the word client and an example of what it is that I want, and then I'll come down here and I will do this. I'll say re.findAll. I'm going to look for that inside of my file content. And it finds, you'll notice that the results come back here and it says, all right, I found this one entry that's in there. Now, what I can do is I can modify that regular expression. Let's see if I can make this a little smaller so it fits on the screen better. There we go. And I'm going to put the things that I'm interested in inside of parentheses like this. Now, these parentheses are called capture groups. It says only extract the things that's inside the parentheses. And so there you can see, even though it matched on the word client and all of that other information, it only gives me back the things that are in parentheses. The reason that's useful to us is because what I'm going to do here is I'm going to use another trick. Now, this regular expression looks for exactly this string: client, this IP address, colon, this port, query, this host name, and of course, it only finds one instance of that entry. But what I can do is I can take the stuff that changes on every single line of my log file and I can replace it with three characters: dot, asterisk, question mark. Those three characters are roughly equivalent to an asterisk at the command line. That means anything can go here between query colon and the word in. Query colon space, space in. Anything can go there. And so I'll put an asterisk or a wildcard there. I'll put an asterisk or wildcard here for the port number and for the IP address. So that says I'm going to have the word client space anything, pound sign, anything, colon space query colon space anything space in space a. It's going to look for that over and over again in that file. And when it does, it finds this list that has all of these different entries here. As I span it out, you can see it finds all of those. Okay, so that's useful. Now, I don't want the word client, and I don't want the word query, and I don't want in, but I have to have those there for me to be able to say, hey, I'm looking for client anything pound sign, right? I need something that's before and after it to be able to use those that asterisk, right? The wildcard, three characters, dot, asterisk, question mark. So I need something before it or after it just to be there, but I don't want it in my results. So that's where we can use those capture groups. So I can put parentheses around that three character combination of the things that I want. If I just put one set of parentheses around the IP addresses, then I get back this list that has, well, all my IP addresses in the list. If I was to put parentheses around my IP addresses and around this host name, well, now I get back a list that has both the IP addresses and the host names in it. And that's exactly what I want for each file. So now that I've kind of experimented with this down here in this debug console, where this is just like sitting at a Python prompt here, by the way. This debug console, I can interact with variables. I can do anything I want to there. But now that I've figured out that this regular expression is going to do what I want, I can come up here and I can then put it into my code. And I'm going to call this IP and host equals that. So that'll retrieve that value. And so then I know that these tuples, this is called a tuple, it's going to have two items. What I can now do is I can say for each IP, comma, each host in IP and host. So I'm going to go through all of those results. I can say if each IP is equal to the one that I'm looking for, which is going to be in variable the data, then what do I want to do it? I want to put it in to the answer list, right? So I'll say, let's do something like this. Answer is going to be equal to a list. And I'll say answer.append. What is it that I want to append? I want to append each host, right? Because I'm trying to find all of the things that were looked up by that IP address. And then down here, I can return the sorted answer. What I'm going to do is I'm going to put a breakpoint here, save it, and I'm going to try and start debugging this again so we can see what's happening here. All right, so we are processing our first file. Each file, as I see here, is 9.log. So we're opening up 9.log. We've read our content already. We've done our read lines. We got our content. Now we're going to pull out our IP addresses and hosts. Let's let that happen. And look, there's our IP addresses and hosts. We got all our IPs and all our hosts. Now we're going to say for each IP and host in that list, so this should create now two variables for us, each IP and each host. And it does. Each IP contains the first IP address from my list, right? It contains this IP address here, and the host contains that host there. So we are stepping through each of the items in that list one at a time. And we're saying if the IP address is equal to the data, here's my data. This one is not going to be equal, so we'll notice that it will skip. It will not put that in my answer. It'll just grab the next one. We're going to see, does this one equal it? Nope. All right, and it's going to continue that process. Let's put a breakpoint here on 14 to get to one where it does match. So I'm going to click play, and oh, there were none in that particular file. So it went all the way through log 9, and it didn't find any results there. So let's get the next one. Okay, so that only processed one of the files. I'm showing you this to show you this is an error that I frequently see students make. That is, it is important to understand what spaces mean in Python and where things are put. Let's step through this one more time. I'm going to start debugging this again. When we start debugging it again, we're going to see that we reach this first breakpoint. Okay, and now we are processing log 9. Okay, we're doing log number 9. And we pull out all of our IP addresses. We go through each of our hosts. We're going to look and see, are there anything there? And then when we're done with that file, when we're done with this for loop, we'll come down here to line 15. Let's let that run. When it reaches line 15, it's finished this for loop. Okay, and now we're still on line log9.log. And so now what's it get to? We finished log 9 and we get to return. Well, I don't want to actually return. I want to still there's other files that are in this log file, but because return is indented beneath this for loop, well, it's going to exit. A return means leave the function immediately and don't do anything else in the function. So it's important that that return statement not be indented beneath that for loop, that it be, well, back as you see it there. This is going to allow all of the lines that are indented beneath the for loop to run. So it's going to do each of those lines where it's going to read the content, pull out the IP addresses, and then add those to my answer for each of the log files. And then only after it's done it for all of those log files will it return. Let's watch that happen. So we'll start debugging again. Okay, so we are on log 9. Pull out all the IP addresses, and we'll let this run. All right, notice now we're on log 17. So it processed all of log 9. Do I have anything in my answers? Let's look at answer up here. No, answer is empty. So there were no entries matched in log 9. How about log 17? Still nothing in log 17. How about log 11? Notice answers is still blank. Let that run. Log 11 had nothing. How about log 12? Nothing. 13? Nothing. 10? Nothing. 15? Nothing. 14? Nothing. 16. But 16 had an entry in there. It found one entry. And so now when we'll let it run until it reaches line 15. Now it would return back our sorted answer, which would contain drive.com. Okay, so this looks like that's going to successfully pull out all of the IP addresses and host names from that particular file. So let's go ahead and click stop there. And now what if I could remove my breakpoints, or I could just come up here and say run without debugging, and this would let this program run through completion. So down here at the bottom, what we see here is it queries the data. It's going to give it a different IP address that it's processing. It's going to look up those IP addresses, and it's going to return back the sorted answer. So this function here is working very nicely. Down here, you can see it says correct, already scored. But what I could now do is I could take this function. Let's just copy that, come back over here to our Python interactive shell where we were playing PyWars before. If I paste this in, Now I got a function def lab, lab 333, that if I give it an IP address, 1.1.1.1, it'd give me back, well, a list of all of the hosts that match that. If I give it a D, let's look at a d.data for lab 3.3.3. If I was to call it and give it that IP address, I get back a list of the hosts that match that IP address. So if I here call it and give it a d.data for lab 3.3.3, this will run first. It'll go off to the server, say, what data do you want me to query? I'll then pass that IP address to lab 333. I get back a different results for each of these different pieces of data. Then I can just submit that as my answer. If I put in d.answer, and there you can see I got that correct. So this technique of grab a line, then go through and change all of the things that change on each line to dot asterisk question mark, and then put parentheses around the stuff you work. This is a repeatable process that you could use to pull data out of just about any kind of log. This very repeatable process will let you pull information out of just about any kind of log file. And then it's just a matter of applying some analysis techniques. Now in 573, we'll go into in depth as to how you can do things like look up IP addresses and see if they are known to be associated with countries that you don't do business with, or pull out IP addresses and look them up in threat intelligence feeds to see if they're known to be associated with bad actor campaigns and things like that. Okay. All right. Well, this is just a little bit of insight as to how we could process files in an automated way, be able to pull things out. And of course, if you have attack signatures and things like that that you want to look for, you want to look for specific login codes. It's just a matter of pulling out the information and then, of course, looking for things that match specific criteria that you want to filter on. But first step is extracting the information that you're interested in. And you can use the technique that we've seen here in order to do that. If you found this technique useful, if you'd like to get more information on what we're doing with this, how we're doing the analytics afterwards, how to do for loops, how to process those files, then come check me out in 573. Again, I apologize for any background noise and things like that that happen as I'm recording this from a hotel. But I hope you've enjoyed this session. And please do come back this afternoon for my 673 session, where we'll be talking about a vulnerability in the pickle protocol, which is how Python does its serialization.